In my particular area, in particle physics, what we teach, in my opinion, is the real frontiers of physics. This is where we're really looking at the constituents that make up the universe and the forces that govern those constituents. And what the students get out of it, firstly, is the knowledge that we're pushing the frontiers back at that level. And secondly, they get to find out about all the techniques, the experimental techniques that we're using. And those techniques have a big impact, not just in particle physics, but in the wider field of technology. Obviously, the World Wide Web was invented at CERN. That's a typical example of what comes out. But there are lots of other technologies that we use that students will find useful, not only in particle physics, but in many other applications across the field. We have experiments that last in their first year for either 2 or 3 whole days. As they progress through the second, third, and potentially fourth year, those experiments broaden out. They get much longer. By the fourth year, they can be 48 days long. They turn from standard experiments where the students can be more or less guaranteed to get the results out, till in the end, open-ended research projects where even the staff don't know what the results are going to be. Within particle physics, we have a range of different experiments. We're part of 2 of the major experiments working on the LHC. That's ATLAS and LHCb. They're 2 of the big experiments there. But perhaps a little bit more unusually, we also have a lot of experience in experiments away from CERN, mainly including neutrinos. We work on an experiment called MINOS Plus, which is out in the States, working from the experiment facilities at the Fermi Lab near Chicago. We also have interest in neutrino experiments which will be positioned down in Antarctica. So there is a wide range of particle physics activities that we're involved with. And those are all open as projects that our fourth year students can opt to take.